Okay, today we're going to do 4% of change. So percent of change is the ratio of amount of change over the original number expressed as a percent. Okay, so it's and sometimes we use change, the amount of change, we use oh goodness, we use that as we'll write it as a triangle, amount of change over original. Okay. And we'll do some examples. So it can be a percent of increase or a percent of decrease. So number one, the price of a sweater decreased from $29.99 to $24.49. Find the percent of decrease. Okay, so what you do is you just subtract. You do $29.99 minus $24.49. You always put the bigger number first, even if it's an increase. Okay, over the original amount. That's the key. You have to know which one was the original. Well, it went from 29 to 24, so $29.99 is the original amount. Okay, and then you just solve it from there. So this is going to be $5.50 over $29.99, which is 0.1834. I think it even keeps going, but we want this as a percent, so we have to move our decimal over, so it's about 18%. Unless it tells you, you can round to the nearest percent. Okay? Okay, here's one more. In 1990, there were 1,330 alpacas. In 2000, there were 29,856. What is the percent of increase? So even though we started with 1,330, when we do our subtraction on the top, because we don't want negative numbers, we put our biggest number first, minus 1,330, but since it's an increase, our 1,330 is what we originally started with. So we're going to put 1,330 on the bottom. Okay, so this is going to be 28,526 divided by 1,330, which gives you 21.448. Okay, you still have to move your decimal since we're dealing with percent. So it's 2,140, I would say 5%, round that up. Okay, it went up, which is, that's a big jump from 1,330 to 29,000. So yes, it makes sense that it goes up 2,000%. Okay. Greatest possible error. Okay. Half of the measuring unit you are using. So, and we'll do some examples of this. So for example, if you measure something to the nearest 10th place, so the 10th place is 0.1, okay, well then you would divide 0.1 by 2, okay, and that would give you 0.05 would be your error. If you rounded something to the nearest 100th, it'd be 0.01 divided by 2, okay, which is 0.005, so your error would be smaller. Okay, if you're rounding it to the nearest just whole number, okay, so it would just be 1 divided by 2, which is 0.5. Okay, we'll do some examples here. Okay, so find the greatest possible error for the following measurement, 3.5 centimeters. Okay, so it's just asking for how much of an error, when you're going to measure something, how much of an error you want to allow for. Okay, so since it's 0.5 and that's the 10th place, so 10th place, then you would put 0.1 divided by 2, and it's always with a 1. Okay, so 0.1 divided by 2, so it's going to be 0.05. That's your error, 0.05 centimeters. That means you probably can err that big or that small. Okay, now 6 inches is to the nearest whole number. Okay, so your error would be a half. Okay, so it would just be 0.5. Okay, because this is the ones place, which is just 1 divided by 2, which is just 0.5 inches. Okay, now if you go to this one, we're going all the way to the hundredths. Okay, so you're going to put 0.01. Again, you just put it as a 1. Divide by 2, and it should be 0.005 grams. Okay, so it's getting smaller and smaller. Okay, so if you want to find the minimum and maximum area of something, so a bedroom is measured at 13 feet by 7 feet. That means you got a ruler out and you measured it. Give the minimum and maximum possible areas with the error in there. Okay, so since this is to a whole number, okay, our greatest possible error is 0.5. Okay, so for our max, that means how big could it be, you would just add 0.5. So it would be 13.5 feet by 7.5 feet. Okay, that's the max. The minimum, you're just going to subtract 0.5. So it could be 12.5 feet by 6.5 feet. Okay, that is just asking for the minimum and maximum, but it's asking for the area. So you actually need to multiply these two together, okay? And so this one would be 101.25 feet squared, and this one would be 81.25 feet squared, because it's asking for the area. So that's why we multiply them. Okay, but since we're dealing with a whole number, you're just trying to find an error, because when we measure, we kind of round, and so that's going to be our error. We're going to allot ourselves a little mistake there. Okay. Now a percent error is kind of like percent of change. Okay, we find the greatest possible error and put it over the measure. Okay, so you measure a CD's diameter as 12.1 centimeters, find the percent of error. So remember, since this is the tenths place, we do 0.1 divided by 2. Okay, remember it was 0.05, right? 0.1 divided by 2 is 0.05. So you're going to do 0.05 divided by whatever the measure is we're dealing with, 12.1. So 0.05 divided by 12.1 is 0.00413, okay? Well, then we have to move our decimal over 2 places, so 0.4%. So whenever it asks for a percent, we know we have to move our decimal over. Okay, so you measured a CD's diameter as 12.1 centimeters, find the percent of error. Okay, so once you do it, you just move it over, and it's 0.4%. Okay, that's the percent of error. This is our greatest possible error that we want to allot for, and then this is the percent of error. Okay, and here's a little funny, I guess.